Factoring polynomials. We will use this knowledge to solve equations very soon. That's where we're headed. First thing you need to know about factoring polynomials is look for a GCF first. That's a greatest common factor. Always look for a GCF first. What am I talking about? Well, greatest common factor is actually just distributive property. You're just undistributing. When you look at this first example, notice that there are two terms separated by addition, 2x plus 6. Notice that they both terms have a 2 in common. That's the common factor, and that is the greatest common factor. It always needs to be the greatest. Think distributive property. 2 times some number makes 2x. Well, 2 times x makes 2x. Plus 2 times some number makes 6. Well, that would be 3. When you factored, you've written it as multiplication. You've always taken the greatest common factor, and if you re-multiply it, it's always got to equal what you started with. Look at this next one. Pick the greatest common factor. For 3 and 9, they're both divisible by 3. That's part of the GCF. When you have variables, look for what they have in common. They both have an x. Do they both have an x squared? 9x does not have x times x. It doesn't have 2x's multiplied. They only have one x in common, so that would be the GCF then, 3x. 3x times the first spot makes 3x squared. 3x times x is 3x squared, plus 3x times something makes 9x. 3x times 3 makes 9x. For this next one, it's a little more complicated. There are three terms separated by addition and subtraction. I have to find the GCF for all three. 15, 12, and 24 are all divisible by 3. That's the greatest common factor. X cubed, x squared, and x to the fourth, they all have an x. They all have x squared. They all have at least 2 x's multiplied. Do they all have 3 x's multiplied? This one does not. So x squared is what they have in common. It must be what they have in common. Y to the fourth, y cubed, and y squared. Do they all have a y? Yes. Do they all have y squared? That's y times y. Yes. Do they all have y cubed? This one does not. It only has 2 y's multiplied. So y squared is part of the GCF. Then we distribute. 3x squared y squared makes 15 x cubed y to the fourth. Well, I need a 5. When I take x squared times 5 something, I need x cubed. I need one more x to make x cubed. Y squared times something makes y to the fourth. Well, that's another y squared. Plus 3 times something is 12. That would be 4. X squared times something makes x squared. I don't need any more x's. Y squared times something makes y cubed. I need one more y to make y cubed. Minus 3 times something is 24. That would be 8. X squared times something makes x to the fourth. I need 2 more x's to make x to the fourth. And y squared times something makes y squared. I don't need any more y's to make y squared. When I distribute, I'll get my y squared automatically. And there's my answer. Remember, you always look for a GCF first when you factor. The next kind of factoring is standard form. Specifically, standard form with a 1 in front. Because when you have a 1 in front, they're much easier to factor. You can just do it in a split second. To understand how to do that, I've foiled out several questions here. Reminder of how to FOIL. You take x to both. That's x times x is x squared. X times 2 is 2x. You take 3 to both. 3 times x is 3x, and 3 times 2 is 6. When I combine the middle, 2x and 3x, notice that you always combine two things to make the middle every single time. You combine two things to make 5x, and then observe. I need factors of 6. Now I'm trying to go backwards. I'm trying to go back to here. If this was my question and I was factoring it, I'd need two numbers that multiplied by 6. See, they were 2 and 3. But those two numbers would have to add to 5. See how 2 and 3 add to 5? So look at the question. Here's what I want you to be able to say in your head or if I ask you. In this case, you're going to need factors of 6 and they have to add to 5. And in fact, this sign will tell you what to do. And the reason is, look, it's a positive times a positive, which made a positive. And look at the very last one, the red one. And notice how -4 times -7 made positive 28. Well, here I would need factors of 28, and they would add to 11. Now, hang on. The thing is, it's either 2 positives or 2 negatives. You notice how there were 2 negatives? So whenever this last sign is positive, it's always possible that your signs are either 2 positives or 2 negatives. Basically comes down to the middle. If the middle is a plus, you know it's 2 positives. And if the middle is a minus, you know it's 2 negatives. So one more time. I need factors of 6 that add to 5. And they were 2 and 3. And 2 times 3 made 6. Look at the red one, the last one. I need factors of 28. And they have to add to 11. And yes, they have to add to -11. That's why it was -4 and -7. And look up above in the question, -4 and -7. -4 times -7 is positive 28, and -4 plus -7 makes -11. Look at the middle one. Notice that in the middle, I had positive 5 and -3 that I combined together to get positive 2. Here you need factors of 15, and they really add to positive 2. Notice it's positive 5 and -3. But when this last sign's minus, it's really quicker when you combine a positive and negative number. It's really quicker to think subtract. Factors of 15 that subtract to 2. You see how 5 and 3 subtract to 2? It's just that when you place the 5 and 3, really they have to add to positive 2. That's why it was positive 5 and -3. Now, if that didn't make complete sense to you, watch these next couple of examples and you'll pick it up right away. This is standard form. It has 3 terms. 1, 2, 3. The number in front is a 1. That's the quick kind. First thing you should think, this number times this number makes positive 15. Well, the signs are either 2 positives or 2 negatives to make positive 15. If the middle is a plus, you know it's 2 positives. Now I need 2 numbers that multiply to 15, but they add to 8. Well, 3 times 5 is 15, and 3 times 5 is 8, so it is 3 and 5. And of course I need an x times an x to get an x squared. Now if I FOIL, x times x is x squared, x times 5 is 5x, 3 times x is 3x, there's your 8x together, and 3 times 5 is 15. Look at the next one. X times x is x squared. This number times this number makes positive 16. My signs are either both positive or both negative. This middle is a minus. That means it's got to be 2 negatives. Do not make the mistake. I'll get students that do this, and it drives me crazy. They'll go minus and plus, and they'll stick a minus and plus in the parentheses. That's not the way it works. You've got to make positive 16 when you multiply. It's either a positive times a positive or a negative times a negative. If the middle's a minus, it's got to be 2 negatives. Now, I need factors of 16, and they're going to add to -10. 2 and 8. 2 times 8 is 16. 2 plus 8 is 10. So 2 and 8. And you could put them in either order, 8 and 2. It makes no difference. If you put the 8 first and you put the 2 second, it's like saying 3 times 5 is 5 times 3. It ends up being the same thing when you FOIL. Look at this last one. The signs are different. Notice the signs I picked. X times x is x squared. This number times this number makes -24. If 2 numbers multiply to -24, one's got to be positive and one's got to be negative. You can go negative and positive, but one sign must be positive and one side must be negative. It's going to matter where you put them here because the signs are different. I need factors of 24, and they add to negative 5. That's really what happens. But when this last sign's a minus, because you're combining a positive and a negative to make negative 5, you can just think, I need factors of 24 that subtract a 5. How about 8 and 3? Now, when I place them, really, again, they add to negative 5. And that would be negative 8 plus positive 3 combines together to make negative 5. If you haven't seen this next procedure, it'll be a little weird for you. I used to do it this way. I used to say, okay, I need factors of 20, 1 and 20, 2 and 10, 4 and 5. I need factors of 2, 1 and 2. And then when you FOIL, it's one of these times one of those, and then they have to add together to make 13. 20 times 1 is 20, 1 times 2 is 2, that adds to 22. That didn't work. 120, I don't think it's going to work. Maybe it's 5 times 1 and 2 times 4. Hey, that does work. 5 times 1 is 5, 2 times 4 is 8, and that would make 13. I figured out the numbers it's going to be. You can do it this way. It's a lot trickier and a lot harder to learn. I'm going to show you a way where there's no guessing. So if you didn't notice, this is standard form. The difference is there's a number in front. And when you have a number in front, it helps create the middle term. That makes it much, much more difficult. Here's a procedure, though, that will always work and there's no guessing. When you have a number in front, no longer can you say factors of 2 that add to 13. That's because the numbers that create 20, maybe it was 1 and 24 and 5, or 2 and 10, they help create the 13 when you multiply and FOIL. So you got to find another technique. This will always work. When there's a number in front, take the 20, whatever number there is, and the 2, and multiply them. 20 times 2 is 40. Now find two numbers that multiply to 40. They multiply to 40, but they add to the middle 13. I'll show you a trick in class that can make this easier, but I use a table to do it. So you might go through the list, 2 and 20, 4 and 10. Hey, I'm actually close. 8 and 5. There it is, 8 and 5. Notice that positive 8 times positive 5 makes positive 40, and positive 8 plus positive 5 makes positive 13. Now use this information, the 8 and the 5, to rewrite the middle term. So this becomes 20x squared, and split it up. And it doesn't matter which order you go. A lot of times one order is easier than the other, but you get the same answer either way. So you can put the 8 first or the 5 first. I'm just going to put the 8. Plus 8x plus 5x plus 2. First thing is to notice is that 8x and 5x is in fact 13x. I haven't done anything but split up the middle term. Why do you do that? Because we can use something called factoring by grouping to factor this. And the way it works is you look for what they have in common, but in pairs. 20x squared and 8x, I look for a GCF in that first pair. Not in all of them, but in the first pair. In the original question, you ought to look for a GCF in every number first. But at this point, I know that 20 and 8 are both divisible by 4. That's the greatest. The x squared and the x have an x in common. 4x times something is 20x squared, 5x. 4x times something is 8x, plus 2. Now look at the last two numbers. What do they have in common? They have no common factors except 1, and you need to put the 1. You'll see why in just a second. So that's all they have in common is a 1, and if I take 1 times 5x plus 2, I get 5x plus 2. Here's where it gets weird. You now have two terms separated by that addition. And if you look at this first term and you look at this second term, you'll notice they have something in common. And what you do is you treat that something like a GCF. So maybe it's an A, and I'm going to pull an A out of both terms. Now remember, if I had 4xa plus 1a, and I pulled the a out and said, hey, it's a times 4x plus 1, by the way, that'd be correct. There's not two a's there. A times 4x is 4xa, a times 1 is 1a. So I'm only pulling this thing here out like an A, and there won't be two of them, even though you see two there. Just like there are two A's in this expression, when you pull the A out, it's one A in front. Here, they both have 5x plus 2 in them. So I pull that out just like I pulled out the A, 5x plus 2 times. Now this, as a single thing, times the first spot, makes the first term. If I pull 5x plus 2 out, I'm left with a 4x. Notice if I take 5x plus 2 times 4x, I get that first term right there. Now, 5x plus 2 times the second term makes 1 times 5x plus 2, which is just plus 1. So think of it this way. I'm pulling 5x plus 2 out of both terms, separated by the addition. When I pull it out of the first term, I'm left with 4x. When I pull it out of the second term, I'm left with 1. And there's my answer, 5x plus 2 times 4x plus 1. This next one will go faster. It's a standard form. There are three terms. That's what you suspect. We take the number in front when there is a number in front and multiply it by the last number. 3 times negative 20 is negative 60. I need two numbers that multiply to negative 60, but when you add them, they make the middle positive 11x. If two numbers multiply to negative 60, one of them is positive and the other is negative. Factors of 60, one is positive, one is negative, so really they're going to end up subtracting to 11. That would be 4 and 15. However, they really don't subtract to 11. That's just a way to help figure it out because the signs are plus and minus. When you combine a positive and negative in your head, you subtract. They really add to positive 11. And it's 4 and 15. 4 times 15 is 60. How do I make 4 and 15 add to positive 11? That would be positive 15 and negative 4. This is what you use to rewrite the middle, and you can go in either order again. It's going to be 3x squared plus, doesn't matter which order, I'm going to go 15x minus 4x minus 20. The first two have a GCF of 3x in them. 3x times x is 3x squared. 3x times 5 is 15x. When this sign is a plus, you bring down the plus. When this side is a minus, you bring down the minus. 20 both have a 4 in them. Pull out that 4. Negative 4 times something makes negative 4x. That'd be x. And negative 4 times something makes negative 20. That'd be positive 5. Remember, that's a negative 4. Both terms have x plus 5 in them. X plus 5 times. When you pull the x plus 5 out of the first term, you're left with 3x. When you pull the x plus 5 out of the second term, you're left with minus 4. If you FOIL that, you will get what you started with. This one is much easier. Difference of squares is a special case of the easy standard form. See, there's two terms. Really, there are three. The middle term is just 0. I need factors of, there's a 1 here. When there's a 1, I need factors of 16. My signs will be positive and negative to make negative 16. So when I add a positive and negative, I subtract. Factors of 16 that subtract to 0. Well, that's 4 and 4. It's x times x, 4 times 4. And how do I make a negative 16 a positive and a negative? And when you FOIL, x times x times 4, 4 times x, and 4 times 4, it's actually these two here, the outside and the inside, that make the middle term. Positive 4x on the inside and negative 4x on the outside. When I FOIL, they add to the middle 0. Notice the pattern of difference of squares. X squared is a square, 16 is a square, 4 times 4. They got to both be squares, and the word difference means subtract. If it's addition, it doesn't factor. One that doesn't factor we sometimes call prime. For example, if I said x squared minus 25, the middle is 0x. It's a difference of squares because 5 is a square, x squared is a square, and I have subtraction. It's 5 and 5 make 25, and a positive 5 times a negative 5 make negative 25. And when I FOIL, positive 5x on the inside and negative 5x on the outside end up making the middle 0. Once you see that simple pattern, x times x is x squared, 5 times 5 is 25, you can factor some harder ones, like maybe 16x squared minus 25y squared. This is a difference of squares. 16 is a square, 25 is a square, x squared is a square, y squared is a square, and I have subtraction. So how does it work? Well, 4x times 4x is 16x squared. 5y times 5y is 25y squared, and it's a positive times a negative to make negative 25. Just follow the pattern. Back when we did the harder kind of standard form, you did factoring by grouping. How do you recognize factoring by grouping? Well, usually it's 4 terms. There can be some weird cases, but for us it's going to be 4 terms. Always look for a GCF in every number first. There is none in the first example. When you have 4 terms, suspect that it might be factoring by grouping. If I group the first 2 up, they have a y in them, y times x plus 7. If I group the second 2 up, they have a 5 in them. Now, this sign I bring down a minus. It's possible that that sign you bring down you might have to change. That doesn't happen when we do the standard form this way, but when you do a grouping question, occasionally you have to mess with the signs. But in this case, they both have a 5 in them. Pull the 5 out, I get x. Notice this is going to be plus because negative 5 times positive 7 makes negative 35. Notice they both have x plus 7 in them. X plus 7, pull it out, I'm left with a y and a minus 5. And if I FOIL that, I'll see that I get this. Look at the next one. Group them up. There are 4 terms. It's factoring by grouping. They both have a y in them. Pull the y out. I get x squared plus 9. The last 2 have an 8 in them. Pull the 8 out. I get x squared plus 9. Both terms have x squared plus 9 in them. We're going to pull that out, x squared plus 9, and I'll be left with y plus 8. And if I FOIL that, I would get what I started with. Interestingly, if this had been x squared minus 9, it would have been a difference of squares, in which case you would have made it x plus 3 times x minus 3 times y plus 8. But as it stands, this does not factor. You can try to the end of your days, you will not find 2 things that when you FOIL them make x squared plus 9. Not with integers anyway. So in review, greatest common factor is the first thing you always look for. Standard form has 3 terms. If there's a number in front, that's the harder kind. If it's just a 1, then we can just say factors of C that add or subtract to that number there. But we'll group it when there's a number in front. That's when I multiply the first times the last, and I find numbers that make the middle. Difference of squares has 2 terms, and it must be subtraction. It must be difference. They must be squares. Grouping has 4 terms, normally. You group the terms. It's just a special case of the GCF is what it is. The rest of this video is just examples off the assignment if you need some help. So let's take a look at this first example. Remember to look for a GCF first. 25, 5, and 35 all have a 5 in common. C to the 5th, C to the 4th, and C in common, all they have is a C, because this one only has a C. D to the 7th, D cubed, and D to the 7th. Well, they all have 3 D's in them, but they don't all have 4 in them. So D cubed is part of the GCF. And then think distributive property. 5CD cubed times something makes 25 C to the 5th D. Well, I need 4 more C's to make C to the 5th, because this is C to the 1st. And I need 4 more D's, D to the 4th, to make D to the 7th. Plus, and times the second term makes 5 C to the 4th. I need just a 1 to make 5. I don't need to put it as long as I have something there. That'd be C cubed. And I don't need any more D's because I have a D cubed when I multiply. Plus 5 times 7 makes 35. When I multiply, the C will make the C. We're good there. But I need 4 more D's to make D to the 7th. So my answer is 5C D cubed times 5C to the 4th D plus C cubed plus 7D to the 4th. These are super fast. There's just a 1 in front. I need factors of 12 to subtract a 1. They are 3 and 4. Really, they don't subtract a 1. Really, they add to positive 1. How do I make a negative 12? It takes a positive times a negative. And 3 and 4 have to add to positive 1. That'd be a positive 4 and a negative 3. X plus 4 times x minus 3. And you can switch the order if you want. Another quick one. I need factors of 63. My signs are going to be positive and negative to make negative 63. And when I have a positive and negative, I can just think, I need factors of 63 to subtract a positive 2. Well, that's 9 and 7. I know that this number times this number makes negative 63. So my signs are positive and negative. But really, again, 9 and 7 add to positive 2, which means the 9 has to be positive and the 7 has to be negative. Another easy kind of standard form. There's a 1 in front. I need factors of 63. It's either going to be 2 positives or 2 negatives to make positive 63. But there's a plus there, so it's going to be 2 positives. Factors of 63 that add to 16. Isn't that 9 and 7 again? So this would be x plus 9 times x plus 7. Another quick one. Factors of 56 that add to negative 30. Notice that 2 numbers multiply to positive 56. So it's either 2 positives or 2 negatives. That's a minus. It's got to be the 2 negative route. W minus and WU minus. So factors of 56 that add to 30. I believe that is 2 times 28. 2 times 28 is 56, and negative 2 plus negative 28 will make negative 30 when you FOIL. Notice there are 2 terms here, and notice that there's subtraction. 25 and r squared are both squares. This is a difference of squares, 2 terms. The middle is really 0r. I need factors of 25 that positive and negative that they'll subtract to 0. And the pattern is 5 and 5. It's r and r to make r squared, 5 and 5 to make 25, and it's a positive and a negative to make negative 25. And when you FOIL, the inside is positive 5r, the outside is negative 5r, and you combine those together to make 0. Another difference of squares. 4 is a square, 81 is a square, I have subtraction, and x squared is a square. The pattern is squares, 2x and 2x, 9 and 9. Got to make negative 81, so that'd be positive 9 times negative 9. And when you FOIL, F-O-I-L, the outer and the inner make the middle. That would be positive 18x, and the outside would be negative 18x. And when you combine those, you'll get 0 in the middle. Here we have a standard form with a number in front. That's where we'll go 2 times -10 makes -20. I need two numbers that multiply. They multiply to -20. But when you add them, there's a 1 in the middle. They add to +1. How about 4 and 5? Now they got to add to +1, which means the 5 has to be positive and the 4 has to be negative. This is what we will use to rewrite the middle term. 2x squared, doesn't matter which order you go, minus 4x. Sometimes one order is easier than the other, but you'll still get the same answer. It'll just be flipped around if you go in a different order. Minus 10. Pair them up. First two have 2x in them. 2x times x minus 2. Last two have 5 in them. 5 times x minus 2. Both have x minus 2. Pull that out front. And I'm left with 2x and plus 5. If you want to check this, FOIL it out, you'll get what you started with. Another standard form, 3 terms, but with a number in front. I'm going to multiply those two. 20 times 2 is 40. I'm going to find two numbers that multiply to 40, but when I add them, they add to 13. Well, that'd be 8 and 5. And positive 8 times positive 5 makes positive 40, and positive 8 plus positive 5 makes positive 13. We'll use this to rewrite the middle term. 20w squared plus 8w plus 5w plus 2. Hey, this is the same question I did in the example. First two have a 4w in them. That's 4w times 5w plus 2. The last two don't have anything in common, so I just put a 1. 1 times 5w plus 2. Pull out the 5w plus 2, and I'm left with 4w plus 1. Another standard form with a number in front. So I'm going to take the first number times my last number. 4 times -15 is -60. I need two numbers that multiply to -60, but when I add them, they add to +7 in the middle. This is a little bit of a tough one. Well, 5 times 12 is 60. And again, I'll show you a trick in class to find factors. I need them to multiply to -60. One of them's got to be negative, but they have to add to +7. So I guess I'm going to have +12 and -5. I'll use these two to replace the middle term, and I get 4z squared. Doesn't matter which order you go. I can either put the -5 next or the 12 next. Well, I see the 4 there. I think 12 would be better with the 4. 12z minus 5z. And notice that 12z minus 5z is still 7z minus 15. I'll pair them up. These two have a 4z in them times z plus 3. And the last two have a 5 in them, and I'll bring down my minus 5, and z plus 3. -5 times 3 is -15. Comes out right. Both terms have a z plus 3 in them. Pull that out. Times 4z minus 5. Another standard form. I'll take 4 times 15. 4 times 15 is 60. I'm looking for two numbers that multiply to +60, but when I add them, they add to -23. And that would be 3 and 20. Notice they have to add to -23. They're both going to have to be negative. Factors of 60 that add to -23. I'll use this to rewrite the middle. I can either put the 3 first or the 20. -3 or -20. I'm going to do the -20 because I like that with the 4. Again, notice that -20 minus 3 is -23 plus 15. First two have 4w in them. 4w times w minus 5. minus, bring down the sign, they both have a 3 in them, 3 times w minus 5. That's because negative 3 times negative 5 makes positive 15. Pull out the w minus 5, and it's w minus 5 times 4w minus 3. At first glance, this one looks like a standard form. Notice the directions are factored completely. They're giving you a clue. Later on, they won't tell us that because we'll be solving different kinds of equations, and you always have to remember to look for a GCF first. And you'll see that right here, they all have a z in common. Z times 8z squared minus 6z minus 9. Forget the z for a minute. It is part of the answer, and we will need it. But just look at this and notice it's a standard form. Not only that, it's the hard kind of standard form with a number in front. I'm going to take 8 times negative 9. 8 times negative 9 is negative 72. I need two numbers that multiply to negative 72, but when you add them, they make negative 6. If they multiply negative 72, one's positive and one's negative. And honestly, I am pausing and thinking about this for a minute. I did find them. They were 6 and 12. 6 times 12 is negative 72. I need 6 and 12 to add to negative 6, which means the 12 has to be negative and the 6 positive. Notice these two multiply to negative 72, and when you add them, you get negative 6. I'm going to use that to rewrite the middle term. 8z squared. Doesn't matter which one you do next. I'm going to do a minus 12z plus 6z minus 9. Notice that negative 12 plus 6 makes negative 6. First two have 4z in them. 4z times 2z minus 3. The last two have a 3 in them. 3 times 2z minus 3. Pull out the 2z minus 3. And it would be times 4z plus 3. Don't forget, this thing here is part of the answer. If you leave it off, this would not foil to what you started with. You must have the z as part of the answer, so don't forget it, or when you enter it in your blank, it'll be wrong. This one's a little easier, but again, we're pointing out, and it doesn't say factor completely. You always need to factor completely, and you should always look for a GCF first. 72 and 50 are both divisible by 2 at the very least. So let's pull that 2 out. 2 times 36x squared minus 25y squared. 36 and 25 don't have any more common factors, so we're good so far. This is a difference of squares. 6x times 6x makes 30x squared. 5y times 5y makes 25y squared. And it's got to be a positive and a negative to make that negative 25y squared. Bring down the 2, and you have your answer. Last example, and if you made it this far, I congratulate you. Notice there are 4 terms. This is a clue that it might be grouping. The first thing you would do is look for a GCF in all 4 terms. There is not one. So let's see if it groups. Take the first 2. Note that they both have a y in them. Y times x plus 3. The last 2 both have a 5. I'll try bringing this sign down. If it doesn't work, I'll switch it and make it a plus. But I'll bring down the minus. Remember, that's a negative 5. Negative 5 times something is negative 5x. That'd be x. Negative 5 times something is negative 15. That'd be positive 3. Looks like we're good. If it didn't work and this had been something different, you can always try flipping that sign, making it a positive and changing both inside to negative. Sometimes that works. We can pull x plus 3 out of both terms, and we're left with y minus 5. If you want to check it in your head, FOIL it, you should get what you started with.